Hello everyone. In this video, we'll learn the need of staad pro and for staad pro. But before we go into the need of it, we should first understand what staad actually is. Staad is an acronym for structural analysis and design. And more or less, the acronym itself explains a lot about staad pro. For example, it has three keywords in it: structural, analysis, and design. We'll talk about these a bit later. First, let's go into a bit of history about staad pro. staad was originally developed by Research Engineers International in 1997, which was later bought by Bentley Systems in 2005, which currently owns it. Bentley defines staad as a structural engineering software product for 3D model generation, analysis, and multi-material design. And this, in fact, is quite an apt description of staad. staad helps in creating a model which can be interpreted in 3D as well. It helps analyzing that structure with respect to various conditions of load and support. And finally, it helps you design that structure with different materials. So what can staad actually do? With the definition, you have a fairly good idea of what staad could do. So it can do structural analysis and design of buildings, of bridges, of transmission towers, stadiums, of highway structures, of dams and retaining walls, of turbine foundations, of containment structures, tunnels, culverts, etc. etc. Technically, it can almost do the structural analysis and design of most of the structures you can think of. staad hence is used primarily for two basic purposes. The first is the design purpose itself. Almost every civil engineer you know would have heard about staad because of its extensive use in designing, primarily because it helps you save time as well as minimizes a lot of mistakes that you would normally do in calculations. It is also used for research purposes by students, by teachers, by research scholars themselves to create projects, to create designs which are purely educational in nature. So I'm hoping that you lie somewhere in this realm. Either you are a design engineer who is actually working on practical projects, or a research scholar who is working to either understand structures, its analysis and design, or is working on creating a project of some kind. Whoever you are, the most important question that you must be having is, what do I actually need to know before staad itself? And the answer is, in fact, very simple. staad consists of three basic parts. The first is an input, second is the output, and third is the design. Input in the language of staad stands for structure, that is, model creation, defining of its support, and defining the loads. The output stands for the reactions, the displacements, the member forces and stresses which are a resultant of the input. And design is using this output to create a multi-material design. We'll talk about these components in a bit of detail. Let's first talk about input. So as I said, inputs consist of defining the structure, creating its support, and defining the loads. Structure consists of creating different members in a specific geometry and as well as defining those members. For example, on the right, you can see how staad defines its various members. As you can see, you can define it as a circle, rectangle, T, trapezoid, and so on. The next part is defining the joints of the geometry. On the right, you can again see if you want a fixed joint, you want a pin joint, and so on. And finally, you get the option to define the material itself. When you're defining a member, you're defining the geometry, but here you are able to define the material itself. You get the option, as you can see on the right, to define the material properties like Young's modulus, Poisson's ratio, density, thermal coefficient, and so on and so forth. And this, in a sense, the member, that is the model, as well as the member geometry, the joints, that is the connection between the members, and the material of the member itself. These three sum up to create a whole structure. The next input which you need to understand is the support. On the right, you can see the various staad supports. In general, we tend to use the fixed support, the pin support, the roller support, and occasionally the spring supports. I'll talk about these supports in much detail in a later movie. The third input is the loads. On the right, you can see the type of loads that staad supports. But in general, we tend to use the self-weight of the structure, different point loads acting on the structure, the different member loads, that is UDL, UBL, that is uniformly distributed load and varied distributed load, etc. Area loads, floor loads. We'll talk about the differences also in a later movie. Seismic loads, that is the effect of earthquakes, and the wind loads. In general, you need to have an understanding of all these loads and where those loads are applicable. This is a staad sample of the input. So here you can see the geometry of the structure as well as how the geometry of each member has been defined. It has here been defined as a rectangular member, as you can see in the 3D layout. You can see the support. In this case, I've defined them as fixed support. And finally, I have given it various loads like member loads and point loads. So let's move on to the next most important thing you need to know before learning staad, that is the output. Now the outputs consist primarily of reactions, the displacements of the members and the nodes, that is the joints, the member forces, and the member stresses. As you know, in a 3D joint or a 3D support, 6 types of reactions are produced. 3 are forces and 3 are moments. The forces consist of Fx, that is the force in the x direction, the force in the y direction, the force in the z direction, as well as moment resistance in the yz plane, in the xz plane, and in the xy plane, which we term as mx, my, and mz. The second output which we need to look forward to is the displacements. The displacements can be of the node or of the member itself. The next is the member forces those inputs have produced, which consists of axial force, of shear force, of bending moment, and torsional moment. And the effect of these forces are summed up into stresses inside the member. So here you can see the reactions. On the left, you can see the X, Y, Z, which stands for Fx, Fy, and Fz, as well as Mx, My, and Mz. It is quite clear that since this is a 2D structure, you won't be having any force in the Z direction, as well as no moments in the YZ and ZX direction. The same goes for the other support. And at the bottom, you can see the two nodes which are named. And this is just different ways of showing the same thing. The next sample of the output is the displacement. On the left, you can see the movement of the structure because of the loads. It has been exaggerated to show you the movement. On the right, you can see the tabular data of the displacements. If you remember from the previous slide, node number 1 and node number 4 are the reactions, that is this and this, and hence you can easily see that there is no x, y, or z displacements in 1 and 4. The other nodes, that is 2, 3, 5, and 6 have some displacements. Also, you can see that there is no horizontal displacement in the z direction. This is also because the structure is a 2D structure with no forces along the z-axis. and hence there is no rotation for the nodes too. The next output is the member forces, which in essence is the most important output which we need to understand and have the knowledge of as well. That is the axial forces. This is the axial force diagram of the structure sample. This is the shear force diagram, the bending moment diagram, and the torsional moment diagram. Using these diagrams for the values, you end up creating or designing the member itself. These member forces translate into the member stresses. The third important criteria which you need to know before knowing staad is design. So staad can help you design almost any material. In general, we use it to design concrete structures or steel structures. This is the RCC design of the sample staad project I have shown you earlier with the inputs and outputs. So what you don't need to know before staad. We have talked about understanding of inputs, that is structure, support, and loads. You need to have an understanding about the outputs, that is the reactions, displacements, forces, and stresses. What I intentionally left out while telling you this is how we go from input to output. And that's where staad comes into picture. Staad does the analysis for you. It does the calculations for you. Similarly, when going from the output, that is the various forces and stresses inside the members, to creating that design, that multi-material design, what I intentionally left out again is how you go from that output to design. Staad does the analysis for you. And that is what you don't need to know. You don't need to stress yourself about the analysis procedures, about the calculations, about the matrix method, about the various structural analysis methods. In a simple language, knowledge of structural analysis is recommended but not mandatory. I have given you the pictorial version of garbage in, garbage out, as well as the standard text version as well, because I want you to embed this in your mind. Your analysis is only as good as your data. A software is devoid of the intuition the person using it has. It does not know whether you have punched in the right inputs or not. If you feed in garbage, you'll get garbage out. It's as simple as that. You need to have an understanding of the inputs, that is, creating the model itself, defining the member geometry, defining the support of the structure, and defining the various load it bears. You need to have an understanding of the outputs. Just a mere look at the outputs and you should know whether you have dialed in the right inputs. And finally, you need to have an understanding of how the design works. A simple look at the staad design and you should know whether you have the right values or not. Yes, you can skip the analysis. Yes, you can skip the knowledge of the analysis. But remember, your analysis is only as good as your data. Thank you.
Hi there, if you like this video, please don't forget to hit that like button at the bottom. Also subscribe to our channel, and if you'd like to stay updated with our videos, please hit that notification bell at the bottom. Thank you for watching.